you say here that particle which is to be traced depending upon the angle also, or the phase angle. So that is to be shown by these list of the figures. And also here frequency determination and computation of the phase angles, and finally summary here. Let us discuss about the what are the objects of the here CRO, and which is to explain about the what is the principle which is to be involving and how it is to be working out of CRO, and what are the uses of the various circuits and which should be involved in this construction of the cathode ray oscilloscope, and what are the essential parts which is to be here included in the CRO, and what is the purpose of these parts, and what are the components of the CRT cathode ray tube, so that which is to be focusing of the electron beam here, and here what are the different types of the amplifiers, X amplifier, Y amplifier, and which is to be used in the CRO, and the sweep generator, and synchronization circuits, and what are the applications of the CRO in measurements. And in this here let us discuss about the introduction of the CRO, which is a versatile testing and measurement instrument with an extensive range of applications covering particularly in every branch of science and technology. So let me give you one best example here in hospitalized, and as well as in electronic lab also, you can able to observe that whenever if you consider a RC coupled amplifier, so that when RC coupled amplifier single stage or two stage here, when such a voltage which is to be giving to the CRO in input section by the in RC coupled amplifier, and how the strength of the signal which is to be enhanced. That means if 2 voltage is given to the input, and by the RC combination, you can easily identify that there should be a 7 or 6.5 voltage which is to be enhanced. Okay, that should be observed by you connecting to the output is a CRO, cathode ray oscilloscope. There you can easily observe that. In this section, you have to say that oscillator oscilloscope. That means the DC which should be converting into AC, pulsating AC. Okay. So in oscilloscope, you can able to observe that whether it is a sine wave or cos wave or triangular, square wave, sawtooth wave, every wave you can able to observe, and you can measure the voltage or you can measure the current. Okay. So everything which is to be possible on that CRO, you can able to find out that what is the intensity and what is the amplitude. Okay, and also you can easily find out that here how the Lissajous figures. Okay, whether it is a elliptical path or whether it is a circle path or it is a straight line, and you can easily find out that if it is going to be moving in a positive wave or in a negative, and here the shape of the here 8. Okay, that is to be observed by the CRO here. And the best example is here in hospitals also, when the patient is in a admitted in a ICU, there only immediately the persons which is to be connecting to the ear CRO, that means what is the heartbeat and how the pulses which is to be here pulse rate here, and what is the blood pressure, everything which is to be counting by the here CRO. Okay, you can easily identify that. That's why here in every branch of science and technology, the CRO, cathode ray oscilloscope, which is to be here utilized. Okay, and the next one, and it can display rapidly changing electrical quantities, and it can be used for the measurement of the voltage. Just now we discussed that current, phase, and frequency in detail. Okay, and mainly which consists of one CRT, that means cathode ray tube. That means on the tube the electron beam which is to be projecting, and that means some important electronic circuits like amplifier, sweep generator, synchronizer, and so many which is to be present. Next, what is the basic CRO operation here? So the major subsystem of the general purpose oscillator, which is a block diagram. So you can see here. So this is the CR1 here. So which consists of input signal, the voltage, vertical amplifier, which can divide the volts with respect to the divisions, and delay line, and which is sending to the vertical plates, as well as there is a electron gun is there, which is to be projecting like that. A horizontal plates is there, that means X cut and Y cut, or X plates and Y plates, and the electron beam CRT. There is a screen which is sending. So in this, there is a HV supply is there, and also LV supply is there, and horizontal amplifier, time-based generator. Here also time with respect to divisions, and also triggering circuit is there. Okay, so like that, you have to draw the circuit diagram for that. So what are those terminology in the block diagram of the CRO? That is also to be mentioned. VA means vertical amplifier, and PS is power supply, CRT cathode ray tube, TC means trigger circuit, and TBT time-based generator. HA means horizontal amplifier, S means screen, EG means electron gun, EB means electron beam. That means the electron gun which is sending the electrons, and which is projected like a beam here. The beam contains the more number of electrons. And H means horizontal plate, and V means vertical plates. Okay, so IS means input signal. So what is the basic principle which is to be involving in this? Let me give you the in detail. That means the electron gun means which consists of a cathode. So that the grid and the two anodes, which are for accelerating and focusing and also producing the electron beam, and which is to be focused on the CRT fluorescent screen of a CRT, so that the point at which the electron beam, which is to be hitting the screen, which is to be appear like a bright spot due to the fluorescence. That means there should be look like a green spot on the screen. That is a fluorescent screen. Okay, so the invisible stream of electrons can be visualized in the screen of the tube, which is in a luminescent spot. That spot which is indicating that electron is there, electron beam is there, and which is sending the electrons toward the screen here, and which is before it is striking the screen, which is going to be passing between the two sets of plates, which are called as a X plates, that is a horizontal deflection plates, and also Y plates, that is a vertical deflection plates. So that the position of the electron beam, that means the position of the spot on the screen, which can be controlled by the applying appropriate voltages to the deflection plate, whether it is to be connected to the X plate or Y plates, like that, by depending upon the voltage which is to be deflecting and which is passing towards the screen and focusing on the screen here, so that the voltage whose time variation which is to be displaced applying to the X plates, either directly, or an amplifier which is called as a horizontal amplifier, and then applied to the X plates. So that this is a small brief description about this control of the CRO oscilloscope. And let us know about that. What is CRT cathode ray tube? So this is so many times this question is asked as essay question. Please be focus on this. So in simple manner, you have to write it down. No need to write entire thing. What do you understand from the concept here? And you have to draw the block diagram. You have to mention the each and every terms here. And later on, you have to write it down that what are the main controls which are to be involved in this CRO. So that you have to write it down. Okay. So next one.
Bank credit card. You get access to life.
First is that Electron gun assembly, the CRT, which includes the electron gun. The figure point 12.1 is not there. This is this one. This is the figure. Okay. So this is the screen on the right hand side. Left side is the beam which is to be sending the electrons, and in between there is a pre-accelerating anode is there, and also focusing anode and accelerating anode. Okay. High voltage supply is to be given out. So see here, the electron gun. So the electron gun which produce the beam of the electron, and which is to be mounted in the tubular neck of the CRT. Here you can see here. This is the electron. This is entire CRT. CRT is a part of the CRO. Okay. So which consists of electron gun on the left hand side. That means which can send the electrons toward the screen, a beam of electron. So the source of the electron, which is an indirectly heated cathode, then the cathode is completely surrounded by a cylindrical electrode, which is called a control grid, which is a small aperture at its center, coaxial with the tube axis, and the grid is mounted on the small negative potential with respect to the cathode. And this facility is passing through the grid control of the number of electrons, which is making up of a beam here, and this can control the brightness of the what do you say, trace on the screen, and the knob on the front panel of the CRO control the grid bias, which is known as the intensity or brightness of the control. Acceleration or focusing of the electron beam, and you have to know that the electrons which are emitted by the cathode after passing through the small hole of the control grid, and which are to be accelerating toward the screen by high positive potential, which is applied to the here two accelerating anodes here. Whenever high potential which is to be giving to the electron here, those are to be accelerating, and which are to be focusing on the anode, and again which is to be accelerating the anode here. Okay, before pre-acceleration by applying such a voltage to that, and these are to be passing toward the screen and focusing on the screen. So like that, these are the, there should be a continuation. That means what type, how many, that means pre-accelerating anode and accelerating anode, which are to be maintaining here high potential here, positive potential, just like a 1500 voltage, which is to be needed. So the focusing anode and located between the accelerating anode, which is connected to the lower potential. That means 500 volts, and therefore these electrodes which are to be accelerating and focusing on the system, and which is defined as the electron beam on the fluorescent screen. Next, the deflection system. So the accelerated electron beam after passing through the electrostatic lens system, and which passes between the two pairs of the metal plate. So what are those? X plates as well as the Y plates. So there only the deflection should be takes place here. So here when these plates are uncharged, okay, uncharged. Therefore you have to see that plate here in figure A, uncharged. So that in other case vertical plates here, there is a first upper part is a positive and below is a negative. There is a deflection in upward. Okay, why? Because of the electrons is a charge of the electron is a negative, which is attracting toward the positive. Getting my point? Deflection, which is an upward. The charge of the electron beam is a negative charge, which is attracting towards the positive. That's why which the arrow mark which is going to be towards in the upward direction. Similarly, if upper plate is a negative and the lower plate is a bottom one is a positive. So that again the electron which is attracting toward the beam of the electron attracting toward the below one. That means the bending is towards the downwards. You have to think like that. There is no charge on the plate. This is the first plate, figure A, straightwards. No deflection should take place. That is the case. Next, fluorescent screen. What is that? The inner wall of the wider end of the CRT, which is coated with a phosphor. A phosphor which can absorb the kinetic energy of the bombarding electrons and re-emit radiation at the lower frequency in the visible spectrum. Okay. So here the property of some crystalline materials like phosphor, zinc oxide, and to emit light when stimulated by the radiation, which is called as a fluorescence. So fluorescent material have a second characteristic, which is called as a fluorescence. That means phosphorescence, and which refers to the property of the material, which can continue the light emission even of the source of the radiation, which is amplified. Then, which is a large gain of the order of 10 power 4 to 10 power 5. It has amplify weak signals until they are large enough to cause a principal deflection on the electron beam. And the displayed waveform on the CRT should be an exact representation of the applied signal, applied voltage, which can vary from the fraction of millivolts to the several hundred volts. Milli means 10 power minus 3. And the frequency which can vary from the 0 to the several megahertz. And this purpose appropriate attenuator, high gain bandwidth amplifier combination, which is incorporated between the Y terminals of the Y plates. Next, sweep generator. Okay, there is a spelling mistake is there. There is a gap, no gap is there. This is also called it as a time-based generator. If AC voltage, just like 220 to 240, 50 hertz, which is applied to the Y plates without any voltage on the X plates. Okay, we are not to be applying any voltage to the X plates here, horizontal plates. Therefore, the resulting pattern of which is a vertical straight line, we are applying only to the Y plates, not to the X plates. And the voltage applied to the Y plates varies continuously between the positive and negative peak values. Therefore, the electron beam follows this continuous variation, moving upward and downwards with 50 times per second, like this. So, due to the pre-resistance of the vision, the pattern appears like a straight line, but the length of the line which can measure the applied peak to peak, positive to negative, and to study the variation of a function of a time, it is necessary to deflect the spot horizontal across the screen in a uniform rate. And also we have to provide a time scale along the X direction against which the voltage which is to be applied to the Y plate. So this is look like a sawtooth wave. Okay. And Y-axis voltage, X-axis with respect to time. So this is a sawtooth generator. Next, horizontal amplifier. This is nothing but a X cut. That means which can magnifies the output of the time-based generator before it is fed to the X plates. Signal needs to be amplified. And the gain of the amplifier controls the length of the sweep of the generator on the screen. Therefore, the internal time-based generator, which is used for the study of the time-dependent functions, and most of the applications like a vertical screen, which is to be displayed as a function of the other signals, not a linearly related to time. And examples are frequency and phase measurements, like a Lysa's figures. In such cases, the internal time-based generator, which is disconnected, and the relevant external signal, which is fed to the X amplifier. Next, to triggered sweep generator, triggering. So that in the free running or self-oscillating time base discussed earlier, the sawtooth wave, uh, which is the voltage rises to a present value, where a flyback is automatically initiated. Then the circuits start generating the next sweep as soon as the voltage reaches the initial value. The time-based generator is sawtooth wave even without any signal to the Y plates. Then the flyback is controlled by the synchronous voltage derived from the Y amplifier or from the external source. Therefore, the flyback is controlled by synchronous voltage. Latter determines which the start of the sweep, and a free running time-based generator external signal application to the a recurrent signal of the constant frequency. So special oscilloscopes are there. In recent times, oscilloscopes with special abilities to deal with the complex problems of science and technology, which have been developed. As the scope of this lesson is limited to introductory quantitative description of CRO. What is that? Dual beam CRO, storage CRO, sampling CRO, digital readout CRO, etc. Next, this question is asked so many times as a short question. Lysa's figures. See here. What are those? Lysa's figures result when two sine waves are applied simultaneously to the horizontal and vertical deflection plates of the CRO. In general, we have to talk about the Lysa's figures. If a particle is there, two different frequencies, okay, of which are perpendicularly acting upon the same particle. So that how the path of the particle, which look like, whether it is a circle or elliptical or an H symbol or in a straight line. Okay. When these two frequencies are in parallel, that is also perpendicular. So like that here, see here, sine wave. So that what is the resultant? By changing the phase also, you can see here. The phase angle is 0 or 360. That is a straight line shape well. A sine wave is there. 30 degrees. Then 60 degrees circle. 90, 120, 150, 180, phase in opposite. Like that. As therefore, the resulting pattern should be like this. Therefore, Ex equals to E sine omega. And also how to determine the frequency determination by using the formation of the Lyser's figures. When two alternating current voltages of different frequencies are superimposed in mutually perpendicular direction, which may use it for the measurement of the frequency. So that's what here in starting onwards I am going to say that according to the Lyser's figures. Therefore, the signal whose frequency is to be measured is given to one set of plates of CRO, like Y plates, and the signal whose frequency is known as, which is capable of being varies to the X plates of CRO. So this is the experimental setup to determine the frequency. So there is a transformer, primary and secondary. In secondary, RC combination. Okay, resistance is variable, which is connected to the CRO. Okay, RLC. So these are the different frequencies. How the resulting path of the particle, which should be tracing out in different forms here, that is to be considered. So what is the ratio of the frequencies? Fy by fx. Frequency along the y direction, frequency along the x direction. Y means vertical, x means horizontal. So number of loops which touches the horizontal line, and how many number of loops which touches the vertical line. So the ratio which can gives the frequency, that is 1:2, 1:3, or 2:1. Okay, different frequency, and also competence of phase angles, sin phi value, y1 by y2, phase angle, is it 5/2, 3π/2, or 5π/2, or 7π/2. Phase angles also changing. Phase measurement. This is another section. So let you know the summary of this. CRO, which can compares of CRT, cathode ray tube, and which is a fluorescent screen of X cut and Y cut, or XY amplifiers, time based generator, triggering circuit, and power supply, and which is used to determine the frequency of a sine wave and a phase angle between the two sine waves. So what are the model questions? There is only one model question is there, and one short is there. One essay. What is that essay? Draw the block diagram of general purpose CRO and label all the blocks and explain the functioning of each block briefly. Okay. And another one is that construct of Lyser's figures with the help of any tag. So this ends our CRO. So by coming class, only one class is left. That is the final one. And again, we will recall that. We should recall that here. What are the important questions and what are the essay questions and the short questions? So that is to be discussed in the coming class, that coming week, with respect to the blocks as well as the respect to the unit. Let us recall that. Okay, by the coming class we will discuss.